So now I'm going to start with some examples from each class address. And this will give you a better idea of how to go through and start creating subnets and how to do the calculations for them. So this first example is a Class C address, and I want to create subnets from 192.168.1.0/24, so each will have a maximum of 10 host addresses for these three VLANs. So I'm going to use this top level network address. It's a /24 default subnet mask, and I'm going to go through and use subnetting to create a bunch of subnets to these different VLANs, wireless, user, and server. So here's a topology. There's a layer 2 switch. This is a wireless access point. Often there's 5 wireless access points, for example. This is VLAN 11. This is a user VLAN, so it's got some desktops. And this is a server VLAN with some servers. So the first step is calculate the subnet mask required for 10 hosts per subnet. So I'm going to start with knowing how many hosts do I need for that subnet. First question. Then I want to calculate that subnet mask. I want to know what subnet mask I need to create that. So there's your trusty subnetting table. We'll locate the hosts. I want 10 hosts. So if I go to this column, 6 isn't going to be enough, so I have to go to the next one. That's 14. It's a little bit more, but it gives you some extra. So that is the subnet. That's 4 host bits then in the 4th octet, and 4 bits assigned to subnet bits. It's a /28 mask, so I'm going to make note of that, the length of the mask. So the subnet mask calculation. So the subnetting table, we've gone through to identify the mask required for 10 host bits. That's /28. So 4 bits are assigned to the host, because there's 8 bits in an octet, and the other 4 are assigned to subnetting. That's shown right there. There's the host bits in red, and the 4 bits are what's left over from the 4th octet for subnetting. And I can get up to 14 hosts, so that's within the requirement for 10 hosts, so that's fine. It's /28, adding up these 4 bits based on position. Number of hosts calculation. So I'm going to calculate hosts here, starting from the right. I'm going to show you how that works to the left and add the bits to calculate the number of hosts. This is the binary. Remember the binary table: 1, 2, 4, 8, 16, 32, 64, 128. I'm counting the number of addresses. So if I go 1, 2, 4, and 8, that gives me 15 possible addresses. And then the number 0, that's 16. So 16 possible addresses I can get as I start flipping these bits between them, between ones and zeros. So that's 16 minus 2, the network and broadcast address, will give me 14 host addresses available. And calculate the number of bits available for subnets then. So we know that there's /28, there's 4 subnet bits, and that gives me 16 possible subnets. So only 4 bits are assigned to hosts instead of 8 bits. And there are 4 bits available for subnetting for the 4th octet, and there it is there, pointing to these 4. So that's what I have to work with. Another way of looking at it is 2 to 4 is 16, with a maximum of 14 hosts per subnet, or VLAN in this case. So that's easy enough. So you can assign 16 different subnets from network address 192.168.1.0. And that's interesting to be able to do that. In this case, I only need 3 subnets because I've got 3 VLANs, and I can assign 14 hosts per VLAN. I can use the additional for expansion purposes, for example. Step 3 is identify the subnet multiple to assign subnets. This is a key part of understanding how subnetting works. So the subnet multiple starts at bit 5 from the right. So these are the subnet bits. So bit 5, know what that bit position is. It's 16 right there. So that's my multiple because that's the bit position. And that's the value of the bit position. Well, that's the first bit. So 16, so you just keep adding on 16 as you go along, and that gives you the network addresses. And there's 16 subnets available. We already got that from the table. And so if you count these, you get 16 different subnets. So step 4, calculate the network address, broadcast address, and host address range per subnet. So there's the 0 subnet, and that's 192.168.1.0/28. So that's the 0 subnet. Although the multiple starts at 16, there's always a 0 subnet you can use. It starts things off. Number of hosts is 14. Subnet multiple is 16. So I know what my multiple is. I know the number of hosts for the host range, and from all that I can create every subnet that I want to apply for the network address. There's the first 0 subnet because it's /28. Now I'm using 1 here. It's a 1 address. I could have used 2 or something else, but for this example I said let's use 1.0, but I could have any of these 2, 3, 4, anything else as a top level network address. And that'll give me 16 subnets. I'm going to assign the 0 subnet to the wireless VLAN. And the network address, there's the 0 subnet. .1 is the first host address available to assign to an interface, to a wireless access point. And it goes up to 14, because there's 14 host addresses in this range. And 15 is the broadcast address. So if you know that that's 15, then the next one has to be 16. That's the 16 address. And 16 starts with 7, goes from 17 through .30. There's the 14 host addresses for that range. And then 31 is your broadcast. And then it goes on to 32. And that'll be assigned to the server VLAN. 192.168.1.32 is a network address. And 33 is starting at the first host IP address available. And that goes through to 46 because there's 14 addresses. And 47 is the broadcast address. The next subnet would be .48 if you wanted to add, say, another server VLAN. So the addressing, there's the layer 2 switch again, the topology. And VLAN 10, that's the wireless VLAN. And it's assigned the 0 subnet /28. VLAN 11 I've assigned the 16 subnet. And VLAN 12 is assigned the 32 subnet.